Hi students, welcome to this course, PLC Automation, an Introduction to Programmable Logic Controller. I am Professor Yao. Changing a registered bit status. The keywords: bit set, bit clear, bit follow. Changing a registered bit status. Suppose you wish to change bit 4 in holding register 207 from 0 to 1. Call up register holding register 207 on the screen and completely rewrite its bit pattern. Pushing return would insert the pattern into the PLC CPU. Bit status changes are more quickly accomplished by using one of three PLC functions: bit set, bit clear, and bit follow. The bit set functions, BS. The keywords: the BS functions. Enabled is set to turning the function off. No further effect on the bit. Remain 1. When the BS function is enabled in figure 18.4, bit 4 of holding register 207 is set to 1 if it was not already a 1. Turning the function off would have no further effect on the bits. It would remain 1. This picture shows the bit set function program. The bit clear function. The keywords: the opposite effect of bit set. The BC function. Nothing would have happened. Nothing further happens. The bit clear function. This function has the opposite effect of bit set. The example in figure 18.5 operates on bit 5 of holding register 207. When enabled, the BC function would change in bit 5 from 1 to 0. If you had applied BC to bit 6, nothing would happen because bit set is already 0. When BC is turned off, nothing further happens. This picture shows the BP, a bit clear function program. The bit follow functions, BF. The keywords: enable, disabled, both active and significant. The bit follow functions, BF. Figure 18.6 shows the BF functions as applied to this bit. When enabled, the function sets the bit to 1. When disabled or off, the function sets the bit to 0. Notice how BF differs from BS and BC. On and off are both active and significant in the bit follow functions. This picture shows the bit follows function. The application, the keywords, a bold painting process, a template, is controlled by a PLC contact. Both model patterns. Overwrite the BC. The application involves a bold painting process that uses the bit modification functions. Figure 18.7 illustrates an application use bit status change for BS, BC, and BF. Why square boards are to be painted red in certain areas. There are 16 square sections on the board, as shown. There are 16 spray guns, one above each of the 16 sections, that spray perfect square through a template. This picture shows the spray paint pattern and program. When a spray gun red operates in a pattern of the original holding register 207, the red or white pattern will be as shown. A bit of 1 could cause the corresponding spray to take place. Each spray gun's operation is controlled by a corresponding PLC output coil, which is controlled by a PLC contact as shown. The input contact is described by 2 specified lines, a register number line, a bit number line. Know that you could use an output group register instead of 16 output coils. This illustration uses individual output coils. As both model patterns are changed throughout the day, the red or white patterns will change. For example, square 15 is to be changed from red to white. This change may be made permanently by applying in the BC function as shown in figure 18.8. This picture shows revised spray paint patterns and program. To change square 3 from white to red, apply a BS function to bit 3. To change square 10 back and for the repeatedly between red and white, apply a BF function as shown in the figure. A word of caution. Using BF on the same bits as BS or BC can cause problems. For example, if both BC and BF were working on bit 7 of holding register 207, the BF would probably overwrite the BC in the most PLC models. Homework. Handwriting all keywords and submitting them to course Facebook. Just do the online quiz and see you next time.